So hope you all can hear me. So now onwards, we are going to discuss the revision paper 8 of the series in unit paper class 2026. Okay. So this will be an recording for the discussion which we missed the last time. So today's discussion will be about the MCQ paper. මේ session එකේදී මම discuss කරන්නේ MCQ paper එක. So if you have any other concerns on other questions, you can directly get into me. Okay, so we will carry on the work. Done. Okay, so starting from the first question, dimensions of pressure gradient. Lighting is what's finally. Okay, now lighting is also fine. Okay, so we can continue the discussion. So the first question, dimensions of the pressure gradient. So gradient is nothing but delta P over L. This is the quantity which is called the pressure gradient. So what should be the dimension? So the dimension should be, so dimension of pressure, that is ml minus 1 t minus 2, dimensions of length L, so ml minus 2 t minus 2. That is given in the second answer. So second one. Second question, during a short interval of time, the velocity v in meters per second of an automobile is given by v equal at squared plus bt cube. Okay, where the time is t in seconds. The units of a and b respectively. Okay, so this is a relationship to calculate the velocity, right? So they are asking what should be the units of these a and b constants. T means time. So if this equation is correct, then what should happen? All three terms of the equation should have the same dimensions, right? Like preliminary stuff, right? So dimensions of v should be equal to dimensions of a times dimensions of t squared, and dimensions of v also should be equal to dimensions of b times dimensions of t cube, right? So dimensions of velocity is lt minus 1. So dimensions of a to be found, t means t squared. So a should have the dimensions of lt minus 3, right? When you take this t squared to the other side, it will be in the numerator, so it will again go to the denominator with a minus. Okay, so here if you solve with the dimensions, it will be like this, and v will be equal to lt minus 4. So actually they are asking the units. So after you calculating the dimensions, the unit is simple. Actually, you can either go for the unit test, and I mean directly you can go for the unit. I mean, I thought of calculating the dimensions. Okay, anyway, so these two will be the units that is given in, correctly given in the second answer again. Okay. What directly units හදන්නත් පුළුවන් ඈ. It was about dimensions. Okay. Third question. Critical angle between Sorry about that. The critical angle between the glass and air of an isosceles square prism made of glass is 42 degrees. Fine. How the prism should be kept? It should be how the prism should be kept to obtain the refracted ray Q of the ray P shown in the figure using that prism. Okay, so you have to obtain this Q ray, which is the refracted one, using ray P. P කෙනකෙනා කියලා බැදුනාම Q කෙනකෙනා එන්න ඕනේ. So what is the orientation of this prism to be kept? So the orientation should be like this. මෙහෙම තිබ්බොත් තමයි ඔක වෙන්නේ. This is a isosceles right angle prism එකක් නේ. Isosceles means these angles be 45 degrees each. These two angles should be 45 degrees each. So when the light ray comes like this, it will directly hit this surface, this vertical surface, perpendicular. So no deflection at that surface. Then it will hit this inclined surface. When it hit that inclined surface, the angle of incidence will be what? This angle of incidence now should be 45 degrees, right? So when you hit, so this is all this is at 45 degrees angle. So this light ray hits there. So the normal, the angle with the normal, this angle should be again 45 degrees. Why? If this is 45, this is 45. Then if this is 45, this should be again 45. So angle of incidence, that is 45 degrees, is greater than critical angle, right? Critical angle is given to be 42. So if the angle of incidence is greater than 42, then the scenario after hitting this light ray is, we call it total internal reflection. So after hitting this point, the light ray will be automatically totally internally reflected, or will not be refracted to the other medium. Or incident angle එක වැඩිනේ. So it will bend at this point, and again hit at this point. So again this angle also will be 45 degrees. You can check it later. So if again that is 45 degrees, then what should happen is again it should totally internal reflect at this. So when it do that, when it totally internally reflected at the second surface also, then third light ray, the emergent light ray, should be again a horizontal light ray which is propagating in the opposite direction of P. Okay, so then the answer should be the first. No other orientation can obtain the same light ray. Okay, you can check it later. orientation එක ගන්න බෑ කියන්නේ ආයි කරවල යවන්න බෑ. Then fourth one, a block of mass having charge Q is placed on a smooth horizontal table and is connected to a wall through a spring of constant K, which is initially unstretched as shown in the figure. Okay. So there is an object with mass M, which is kept stationary with an initially unstretched spring with constant. Okay. And this mass got a charge capital Q that is also mentioned. This is now unstretched. Then a horizontal electric field E directed to the right is now switched on. Okay, now they are switching on an electric field to the right. So what should happen is, if an electric field is there, then there will be forces on charges, right? There will be forces built upon charges. So this we can assume a positive charge. When the sign is not mentioned, we can assume it to be positive charge. So the force should be to the same direction of the electric field, right? Okay, so under this force, what should happen? So initially it was at rest. It is at equilibrium because only forces acted on the object was the reaction and the weight. So they were balanced and initially it was at equilibrium. But after this disturbance, now it got a force. Because of that force, now it is going to move to that direction. Okay, now we can see what will happen, because now when it tries to move to that direction, again this spring will be stretched, right? Spring at stretch now. So when this spring gets stretched, now there will be third force, fourth force, right? Weight, reaction, this force as well as this spring force. So under four forces, now you know, if this spring is stretched, now the recurring motion will be a simple harmonic motion. If you remember, this motion will be a simple harmonic motion with some equilibrium position. Okay, so if the block starts to execute simple harmonic motion, the amplitude and the angular velocity. So now I understand the scenario. So amplitude and the angular velocity, that is what we should calculate. Okay. So first, let me find the equilibrium point. So when it comes to simple harmonic motions, when we are talking about this in the theory class, we always say, if you want to analyze this, you always have to measure the displacement from the equilibrium position. Okay? You can't measure the displacement from anywhere else. You always have to measure the displacements from equilibrium point. But after application of this electric field, will that equilibrium position be at the same place? Equilibrium position එක එකම තැන තියෙයිද? නැහැ. මොකද electric force එක එනවනේ. ඕක ආපු ගමන් මෙහෙට මෙයා යනවා. ඕකයි balance වෙන්නේ electric force එකට equal force එකක් spring එකෙන් දෙනකොට. Again, the balance point will be when the spring exerts the same force to the opposite direction, which is equal to the electric force. Okay, so let's say this is the equilibrium point. Now new equilibrium position, and again remember that when we are starting to analyze this motion, this object started the motion at this position. That means the velocity is 0 at this position. The moving velocity is 0. Okay. So we will calculate the distance to the equilibrium position. I mean, it is kind of important for this question. That's why we are doing it. So let's say this is the distance to the new equilibrium position. So at the new equilibrium position, what should happen is the electric force and the spring force should balance. Okay, so let me mark it in a smaller diagram. So this is the spring force and this is the electric force. So these two forces should be balanced. So the spring force is given by kx, right? So at the equilibrium position, I marked the elongation as x naught. So kx naught is equal to the electric force QE. Then the x naught should be QE over m. Let's see why this is important. Okay, so this is the new equilibrium point. So having that new equilibrium position, this object will tend to perform a simple harmonic motion about this point. I mean, to the both sides about this point, this position. Okay, so how to calculate the omega? To evaluate omega, either you have to go with the basics. I mean, either maybe you have to go with f equal ma and solve and obtain that a equal minus omega x form of the equation. So after you obtaining the a equal minus omega squared x formation, now you can get the value directly for the omega. Either way, we don't have to do that. මේ කේස් එක දන්න කේස් එකක් ඇත්තටම හරිද? We all know that if you vibrate an object using a helical spring, the time period was given by what? Time period was given by square root m over k. Actually, this time period is equal to 2 pi over omega. I mean, time period is normally equal to 2 pi over omega. So just by comparing this, you can say that if an helical spring is used, in all cases, the omega should be equal to square root k over m. Just see the position of omega and compare it with this part. Okay. So omega should be equal to square root k over m. So now omega is fine. And now you want to calculate the amplitude. Amplitude means what? If you go for the definition, the amplitude of a simple harmonic motion is nothing but the distance to the position from the equilibrium point when the velocity becomes 0. The distance from the equilibrium point to the position when its velocity becomes 0. Equilibrium point එකේ ඉඳන් velocity 0 වෙන තැනට තියෙන distance එකනේ අපි amplitude කියන්නේ. So initially you remember at this position the velocity was 0, right? and this is the equilibrium point. Then what should be the amplitude? The amplitude should be, by definition, x naught. Amplitude is the distance to the point when the velocity becomes zero from the equilibrium position. That is x naught. So x naught we initially evaluated QE over simple M. So these two are properly given in QE EQ over simple Q over simple K, right? This should be K, sorry. So both these are correctly given in the first choice. First answer. Yeah. I believe you all are sticking with the plans of this paper class. So within these 4 months, I mean, until the end of April, the revision process is basically taken down. Okay, so we are revising the earlier lessons as well as the lessons we learned covered during our theory classes, as well as I'm including questions from the other lessons as well, because some students are there who are taking this paper series who are doing their second or third child, so they already have covered this. So anyway, then question number 5. Question number 5. From the following phenomena, the phenomena that cannot be explained through resonance. Okay, the phenomena which can't be explained through the resonance. A. Riding a swing such that the amplitude is increasing. Okay, so what do you mean by resonance? Resonance is nothing but when the forced frequency matches the natural frequency of some object, that object tends to do like higher amplitudes greater than, higher amplitude compared to the normal oscillation. natural frequency එකට match වෙන forced frequency එකක් බලෙන් දුන්නොත් එතකොට ඒ object එක යාගේ natural frequency එකෙන් ලොකු amplitude වලින් යන්න ගන්නවා. That process we call the resonance. So riding a swing such that amplitude is increasing. So how do you ride a swing? So when you are in a swing, so this is the perfect time to talk about this. When you are riding swing, what you do is you just kind of changing the positions of your leg, your foot. You are just swinging this. So when you swing this foot, when you want to go to the front, what you do is when you reach this position, you just get some initially the foot, the leg is like this, then you swing it forward. So by doing that, what you are doing is you are giving a forced vibration, right? You are giving a forced vibration. You are forcing it to vibrate. So when that forced vibration matches the natural frequency of this swing, then you get a higher amplitude. That's how you go, like you reach higher amplitudes by this swing. එහෙම තමයි ඔයා swing එකේ අර ලොකු amplitude එක ලොකු අර දැන් මේක ගොඩාක් ඈතට යන්නේ. හරිද? හයියෙන් තල්ලුවක් දාන්නේ නැහැ. වෙන කෙනෙක් තල්ලු කරන්නේ නෙමෙයි මම කියන්නේ. ඔයා ඔයාගේ self එකෙන් පදින එක. හරිද? You ride this swing by yourself. So what you are doing is you are matching the force frequency to the natural frequency. So that is correct. That is resonance actually. B. A tall glass breaking when a sound is made from high tone. That is also correct. That is a simple example we always give in the class for the resonance. So when the musicians or those who sing operas, when they sing them, the nearby glasses always break in cartoons. So that is resonance. So C. A tuning fork vibrating when a hit is given to a song. Is that resonance? So there is a tuning fork. It is a tuning fork. So you turn some touch to this prong. You give some touch. Then it vibrates. That is not resonance. That is you just vibrate it. You just give a pulse and you vibrate it. That is not resonance. So in resonance, what should happen is you should match the forced frequency with the natural one. Okay. So in this case of this also, you are swinging your legs with some frequency, right? This is a periodic swinging. So when that swinging matches the frequency of the swing, leg එකේ swing එකේ තියෙන leg එක swing කරද්දී එතන තියෙන frequency එක මේකට match වෙනකොට තමයි මේකේ amplitude වැඩි වෙන්නේ. So this is absolutely resonance. Okay, that is giving you some pulse and you are vibrating it. Damage to a bridge when a military parade marches over the bridge by footing in an order. Yes, that is actually also correct. Okay, so when so in some cases, I mean, nowadays you can't see these kind of things, but in earlier cases when they haven't identified this phenomena called resonance properly, sometimes when the vehicles are driven on the bridge, when their frequency matches the natural frequency of the bridge tries to vibrate to sides. Okay, like dancing bridges. You may have you can search it on YouTube. There are few scenarios happened at different places of in different countries of due to this bridge oscillations. Okay. That is also fine. So which one can't be explained? The one which explained is C. So that is given in third answer. Okay. Sixth question. Two forces of each 5 Newton act on an object in the direction shown in the figure. The resultant force on the object and the direction it moves. Okay. Simply, when some objects act on when some forces act on an object, the object always move in the direction of the resultant force, right? So if we evaluate the direction and the magnitude of the resultant force, you can get the both. Okay, so what are the forces? One force is like this, 5 Newton. The other force is something like this. Okay, so you can, when the forces are inclined, you can evaluate the resultant force. There are a few ways. I'm preferring this way. Okay, p squared plus q squared plus 2pq cos theta. Here, this theta should be the angle between the forces. But when remember, when defining this angle, the vectors should be drawn such that either they are diverging or either they are converging to the same point. This is not the perfect way to define the angle. 60 degrees කියලා තිබ්බට this is not, දෙක අතර angle එක 60 degrees නෙමෙයි. The actual angle between these two vectors should be can be taken when they are marked such that either they should diverge or converge. So let's say I'm redrawing this vector at this position. Now you can see both these vectors are diverging from the same point. And now you can define the angle. So the angle between these two vectors should be 120 degrees actually. Okay. So after you identify the angle, you can evaluate the resultant. Square root 5 squared plus 2 5 cos 120, right? This is substitution to with this. So when you do that, cos 120 is equal to minus half. Remember that. This is equal to minus half. So these two get cancelled and minus 1 is there. So 5 squared plus 5 squared minus 5 squared. So 1 5 squared get cancelled with 1 5 squared, and the final result will be 5 Newton. So what should be the direction? So when the forces acting, when the two forces acting are equal, the resultant should go in the midway, right? The resultant should be such that having the same angle with these two forces. That means each of these angles should be 60 degrees. I mean, you don't, I mean, I can, if you want, I can show it using an equation, but in this case, it is not needed because I think you can understand it. When the forces are equal, the result should go in the mid path. So that is given in BF direction, right? BF direction, my boyfriend, BF direction, that is so 5 Newton and the direction is BF. So answer is fourth answer. Done. Seventh question. Seventh question. Light ray falls on AB surface normally on ABC prism of prism angle 60 degrees. Emerges along AC surface. Then the refractive index of the prism is. Okay. So light ray which falls normally to the AB side falls on the AC surface and emerges along AC. That means so set this AC surface before that. So when this light ray enters through AB normally, there will be no deflection. First of all, you have to identify that there will be no deviation at this point because it is normal, coming through the normal. So when it hit the surface AC, it will go along the AC surface. That means this should be the critical angle, right? This should be the critical angle. So they have mentioned this prism angle is 60 degrees. So if this is 60 degrees, and this angle, if it is 90 degrees, this should be 30 degrees. If this is a 90 degrees angle, then if this is 60, this should be 30. Then again, this is a normal. So if this is normal, C plus 30 again should be 90, right? So the critical angle you can obtain directly considering the ray diagram. What they ask to calculate the refractive index, right? So when you know the critical angle, easily you can calculate the refractive index. How? It is nothing but 1 over sine C. 1 over sine 60. Sine 60 is root 3 over 2. Root 3 over 2. So 2 will be gone to the top. Root 3 will be in the numerator. So this is correctly given in the first answer. Done. Yeah. So the next time when the results come, previously the A-level results was released, and I want to inform you guys this because some people may think like, why didn't I announce the results of students who have written the exam through my guidance for 2025. The case is for 2025 A-level exam, I didn't conduct any class. Okay, for because of some reasons with my currently ongoing some other work, as well as because of my studies, I didn't conduct any full class, or even I didn't go for any individual class as well for 2025 students. So that's why I didn't announce any of those results. Anyway, I congratulate all the people who have achieved good results for the 2025 A-level. So the next time when the results comes, it will be your results. Okay, so it is your responsibility that you give some effort to obtain good results such that it is something, I mean, ඒක ඔයාටත් එකතකට අනිවාර්යෙන් ඔයාගේ result එක ඔයාට මේ බලපාන්නේ and අනිත් අතට ඉතින් අපිටත් පොඩි proud එකක් ගේන්න පුළුවන්. හරිද? So it is on your hand. When the next time the results comes, so when the next time the results comes, so some of your names should be there, and I'll be also found. Okay, so question number 8. 1 kilogram of water in a vessel, it should be in a vessel having negligible heat capacity is heated by an immersion heater of 1 kilowatt within 100 seconds. Within 100 seconds, the temperature rises from 25 to 45 Celsius. Okay, so there should be again full stop. Right? 1 kilogram of water. So when you get this kind of a question, always draw a diagram. That will be much easier to deal with. So you have put some heater there, 1 kilowatt power. Within 100 seconds, temperature rose from 25 to 25 to 45. The rate of losing heat to the surrounding is. Okay. So the power of the heater is given, and they have given within this time temperature also rise from this amount. So we can calculate the heat consumed, right? Because if there is a temperature difference, the heat can be reduced using this equation, but in this case I want rate, so I'm dividing it by time. Clear? This insect disturbing me. Okay. So mass is 1, specific heat capacity 4200, and then the temperature change happened was 45 minus 25 divided by time is 100. So by this you can calculate the amount of heat which is consumed by water. So what should happen first? I mean, this immersion heater will be giving 1 kilowatt, and this amount will be consumed by water. Then the rest should be lost at heat. Let's say Pn. So what is this value? This value comes as 840 watt. So the loss should be 1000. That means 1 kilowatt minus the heat consumed by water, that is 160 watt. This is perfectly given in the third answer. Perfectly given in the third answer. So if you want some additional note to be taken, meantime you can take this. Okay, you can pause the video and take your own notes. Yeah. 9. Saline solution of density 1.1 kilogram per liter is to be given to a hospitalized patient. If the blood pressure in the patient bloodline is 62.7 millimeter mercury greater than the pressure inside the bottle, what minimum vertical height should the saline to be placed from the patient? Something like this. So let's say this is where the needle hits. ඉතින් තමයි patient ගේ ඔන්න cut එක ගහලා තියෙන්නේ. So at this point the pressure they have given, it is greater than the atmospheric pressure but by 62.7 millimeter Hg. කියන්නේ ඇතුලේ pressure එක මෙච්චරයි atmosphere එකට වඩා. So what should be the height to place the saline bottle? That is the question. So how to determine that? So what should happen is, if this liquid need to be flown to the into the patient, if this liquid need to be flown into the patient, then at least the pressure built up by the saline bottle should be enough to balance this additional pressure, right? Because you know a liquid always flows from higher pressure to the lower pressure. So if this side has a higher pressure, then obviously this liquid will not flow. So at least this saline bottle should be equal to balance. I mean, at least should this additional pressure. So the least height. So the pressure X by saline should be equal to balance that additional pressure. So you can't do any calculations by keeping this pressure by this unit. When you have this unit, how to convert this to the Pascal? You can convert this by the Pascal using P equal H rho G, right? So the meaning of this is the pressure exerted by 62.7 millimeters of mercury. And mercury meter height at the in a pressure. So you can evaluate using the equation. Okay, so pressure built up by saline, it should be equal to the height to the saline bottle times the density of the saline, that is given as 1.1 kilogram per liter. This value, if you convert into kilogram per cubic meter, that will be uh, yeah. Okay. Okay. It will 1100. G is 10. It will be equal to of mercury, or maybe I mean, in this case you can't use P equal HOG because they haven't given you the density of mercury. I mean, you can use this equation only if they have mentioned the density of mercury. So that is not mentioned. If they have given some other information, so using that you can again convert this into Pascal. How? They have mentioned that. They have mentioned that. So yeah, I should write it. I'll write it here. They have mentioned that 760 millimeter Hg is equal to 1 into the power 5. 1 into the power 5 Pascal. So we need to calculate how many Pascals will that be for 62.7. So how to do that? So if this much of is represented by this, then you have to divide that value by 760 and then multiply with 62.7, right? Then only you can get the value in Pascal for this 62.7 value. So I'll just write it there. 62.7 divided by 760 times 10 to the power 5. Okay, now you can solve this 1, 2, 3, 1, 2, 3, and there will be 10 to the power 2 remaining. And when you solve this, if you calculate value for H, it should come as 0.75 meter. Clear? It should come as 0.7. That is given in the fourth answer. Okay. That calculation part I just neglected because I feel consumed something. I mean, you have to work on some logarithms to evaluate that answer. You can't use the calculators. So spending that time is not efficient as a class. So I'm neglecting it. By the way, you have to manage it. That's your work. In all the classes which I conduct for A-level students, the first thing which I do is during the first few months, solve, how to solve certain uh, sets of values. So you should have that skill now. So fixed mass of gas is present in a container. The pressure of gas is 1 to the power 5 Pascal, and the volume of the gas is reduced by 12% under isothermal conditions. Done. Okay. The new pressure of the gas system is that isothermal process. What do you mean by an isothermal? Isothermal means temperature stays constant. If isothermal and if fixed mass, what is the law you can employ? Fixed mass, temperature constant now, you can employ the Boyle's law. Boyle's law. So that means the pressure times volume stay constant for the gas. So P1 V1 should be equal to P2 V2. So initially the pressure was 10 to the power 5. Initially, let's say the volume is V. Initial volume, let's assume to be V because they have mentioned any value. But they have mentioned after this process, the volume has reduced by 12%. So if the volume has reduced by 12%, what should be the remaining percentage? Reduced by 12%, that means 82% should be remaining, right? 82% should be remaining. So we need to calculate the new pressure, we will say Pn, and the new volume should be 82%. But when we are writing in that equation, we don't write the percentage, we write the fraction. So how to write the fraction? 88 divided by 100, V. Okay, initially V, now this much of V. V get cancelled, so you obtain the new pressure as 100 divided by 88 into 10 to the power 5. You can solve this. 25 divided by 4, this will be 22. So 25 divided by 22, that will be 1.30 will have again 1, then 22, 80 will have nearly 4, right? So 1.14 into the power 5 Pascal, that is given in the third answer. So the answer for this question is third. That is an easy one. Okay, 11th. So that is also an easy one. When this circuit is connected to a power supply, 2 ohm resistor dissipates power at 2 watt. This one dissipates power at 2 watt. I mean, when they have given it, you can do certain calculations to that. Okay, the power, the total power of the circuit. Okay, so they ask me to calculate the total power. So instantaneously when you see this, you should understand this is a what? This is a Winston bridge. So if some total current comes in this path, if that current passes through this path, you see the current comes to this point has two paths. So in two paths, they have the same ratio of resistance in both the paths. Here 2:4, that is 1:2. Here in this path also 3:6. Again it is 1:2. So if the same ratio mentions, then the middle resistor you can neglect. There is no resistor there. So then this is a simplified version of the circuit. Okay, so they are asking the total power, right? What you have given with? You have given with the power dissipated by 2 ohm. Okay, so when you have given with that power, you can either calculate the current passing through this resistor or the voltage. Okay, in this case, it is easier for me if I evaluate the voltage using the given data. Okay? Because once I evaluate the voltage at this at these two, I mean at the ends of this 2 ohm resistor, then onwards by ratios we can evaluate the voltage across these 4 ohm as well, because it should be just 2 times, because the voltage for series connections, the voltage is proportional to the resistance. If this got some voltage, then twice as this will be taken by this, because the ratio is, the resistance ratio is 2:4, 1:2. Okay, then you can calculate the whole, the total voltage given to the total circuit, and after evaluating the equivalent resistance, then considering the equivalent resistance, you can evaluate the total power. A simple concept. Okay, we will see how much voltage is there in two ends of this 2 ohm. So you just employ the simple equation P equal V squared over R. So the power is 2, should be equal to V squared divided by again 2. So V is simply 2 volt. V squared is equal to 4, then V is equal to 2 volt. So once you find that, now you know what is the total voltage. So the total voltage should be, so because of this ratio, 1:2 ratio, the total voltage should be 2V plus 2 times 2V, right? Let's say V dash. This altogether 6 volts, and total voltage is 6 volts. Okay, so if to evaluate the total power, you can't do it with only the total voltage, but you require the total resistance for this circuit, right? The effective resistance which can be applied, replace this whole circuit, that is called the equivalent resistance. It is again a simple thing. So now after removing this middle path, consider the Vincent bridge. This path will have 6 ohm resistance. Here it will have 9. So what should be the equivalent value? Simply the equivalent value you can calculate when two resistors are parallel. It should be the product divided by the sum. Product divided by the sum. That is here it is 5. Here it is 2. That is 18 over 5 equal to 3.6. Okay. So now you got all what you require. You got all the required information to calculate the total power. Just evaluate it. So the total power should be equal to the total power. I'll be writing it here. So the total power is equal to the total voltage square divided by the equivalent resistance. So the total voltage supplied at the ends, we found it to be 6. 6 square divided by 3.6. 6 square is 36 divided by 3.6 is 10 volt. That is given in the second answer. Okay, that is also a good part. Simple, but still you have to understand certain things. MCQs with this current analysis lesson is always easier, but you have to have the correct idea about this, how this lesson works, and how these currents, voltage work, how they divide in series connections and parallel connections alone. You have to know that. Okay, 12th question. When a sound wave of frequency 300 Hz passes through a medium, the maximum displacement of a particle of the medium is 0.1 centimeter. The maximum velocity of the particle is equal to. A simple question. So when the wave passes, the frequency of the wave is given 300 Hz. The maximum amplitude of a particle. What do you mean by the maximum amplitude? Maximum displacement. I just speak out the word. The maximum amplitude is maximum displacement is the amplitude, right? Maximum displacement ke liye amplitude. So the maximum displacement is given 0.1 centimeter. So the amplitude is given 0.1 centimeter. Maximum velocity. So you know, when a wave passes through a medium, the particles will be in simple harmonic motions. For a simple harmonic motion, the maximum velocity is given by what? For a simple harmonic motion, the maximum velocity is given by a omega, right? Amplitude times omega. So you are directly given with the omega value, a value, that is 0.1 centimeter, that you should convert. You don't need to convert because the values are given in, the answers are given in centimeters per second. So you don't need to convert. 0.1 centimeter times omega. Omega is not the frequency, but when you have the frequency, you can calculate the omega. How? 2πf. We always have done these calculations in the class. The omega is 605. 605. So when you multiply it, you get 65 centimeters per second. 65 centimeters per second. So this is given in the third option. This is given in the third option. Okay, done. Okay. 13th, rocket is projected vertically upwards from the surface of Earth with an initial velocity that is equal to the half of the escape velocity. Interesting. The rocket is projected with a velocity equal to the half of the escape velocity. If the radius of Earth is r, the maximum height it moves up is. Okay. So what is the velocity given? That is half of the escape velocity. Escape velocity, it was given by, if you remember the formula, the escape velocity is given by 2gm over r, right? R is the radius of Earth. So half of its velocity. Okay, so it's like this. So you are projecting with this velocity, you're asking to calculate the maximum height. A simple question like what we found in the mechanics. So what should happen is, in this case, you can apply the conservation of energy. So conservation of energy. So when you apply it, the kinetic energy and the potential energy at the surface. Kinetic energy is half m, velocity is half 2gm over r, that's squared. So kinetic energy at the surface plus the potential energy at the surface. At the surface, the potential energy is equal to, now you can't use MGH. This is a gravitational field question. Like, this is a very huge velocity. When a huge velocity is given to an object, it will go over higher heights. It will go to higher heights. So to calculate higher heights, you can't use MGH because that MGH formula is valid only up to certain level of height. Let's say 1000 meter, and that is not a considerable amount of height. That's why it is valid. So other than, when it goes more than that, it is not valid. So minus g m m over r. At the surface, the potential is given by that. It should be equal to the kinetic energy and the potential energy at the maximum height. So when an object reaches its maximum height, when a projectile reaches its maximum height, the final velocity should be 0, right? Any case, if it reaches the maximum height, the velocity should be 0. So the kinetic energy at the maximum height is 0. Potential energy. Potential energy is equal to minus gmm over the total distance from the center. The total distance from the center is h plus r, right? Okay. Now we have to solve this. So again, I am not going to continue with the whole calculation. So when you make the square, it will be like there will be some simplification, and finally, when you solve for h, you'll get h is equal to r over 3. Okay, you can just arrange those symbols such that this simple H is subjected. So after you subjecting the simple H, then you get the answer. So I'm not going to do that part again. That is some mathematics, man. So you yourself try doing that. I mean, it is already given in the marking, so you can check it after you solve it. So I just wanted to uh, tell you how that happens. I just wanted to give you the idea. 14th. So that is a very easy question. A bullet of mass simple m hits a cube of mass capital M, which was free on a smooth surface and sinks into it. The final velocity of the bullet and the cube would be. Okay. So the final velocity. There is a capital M mass which is initially at stationary on this smooth surface. A bullet hits with the velocity. So they are asking to calculate the final velocity of these both coalescence, combined object. Very easy case. So for any collision, you can use conservation of momentum. So just this is an application of conservation of momentum. So considering a certain direction, you apply the conservation of momentum. So before the collision, the total momentum is mv. I consider this direction, so it is plus mv, plus this one does not have any momentum. So before the collision, this is it. So this should be equal to the total momentum after the collision. So after the collision, the both objects gets combined or coalescence and then move as a one. So the velocity is v dash. So the total momentum should be m plus m times v dash. V dash is simply mv over simple m plus capital M. That is given in third answer. Okay, that is given in the third answer. Yeah. Each of the capacitors shown in the figure has capacitance of 5 microfarad. The EMF of the cell is 50 volt. Initially, the switch S is open. A switch being open means that is not touched, that is not in contact. So open means open, that is off. That off switch. When it comes to switch, there are two conditions. Two states. One is switch on, that is when the bulbs illuminate. The other case is switch off. When the switch is off, the circuit is open. So this is open. How much electric charge would flow through AB when the switch is closed? So initially it is like this. So the switch is open and they are closing it. So how much charge, they ask how much charge is flown. Okay. Simply, this is a capacitor system. Clear? Three capacitors are there. So this is just a system of capacitors. So when the system of capacitors is connected, the whole system, you can, if you want, to simplify certain problems, you can think of a single capacitor which can give the same result. That is what we call the equivalent capacitance, right? So you can think of the equivalent capacitance. So thinking through the equivalent capacitance, realize in the first case there should be some charge. First case මේක open තියෙනකොට equivalent capacitance හෙව්වාම අර Q equal CV use කරලා මේක store වෙන charge එකක් හොයන්න පුළුවන් නේ. Then calculate charge. Then after the switch is closed again to the new circuit. After the switch being closed for the new circuit, again you can calculate the new equivalent capacitance. So for that new equivalent capacitance, again you can calculate the amount of charge stored by the capacitor system. So the previous value will be a different one. So what will happen is that difference of charge is getting flown through AB. කලින් හෙව්වාම එන charge එකයි දැන් හෙව්වාම එන charge එකයි වෙනස් වෙනවා අනිවාර්යෙන්. ඒ gap එක يعني difference එක තමයි මේකේ flow වෙන්නේ. Okay. So we will first solve for the open condition. When the switch is open, this system is nothing but there are two parallel capacitors connected in series with this 5 microvolt. හරිද? මේ පාත් එකේ current එක යන්නේ නැහැ නේ. මේ පාත් එක open තියෙන්නේ. So in capacitors the series and parallel connections work the opposite way to the resistors. හරිද? opposite විදිහට තමයි වැඩ කරන්නේ. ඒතර parallel connection නම් අපිට add කරන්න පුළුවන්. හරිද? So the equivalent value of these two will be 10. So when they are in series, that product divided by sum, you can do it. So that will be 10 over 3, right? Microphone 10 over 3. That is when the circuit is open. So the equivalent is 10 over 3. And now you can evaluate the first, total charge in the first case, open case, let's say QO. It should be equal to, we will say C1 times the total voltage. The total voltage given is 15. So 10 over 3 into 50, that is 500 over 3 microcoulomb. This is the charge stored in the first case. What happens when it is closed? When the S switch is closed, what will happen? Okay. When the S switch is closed, this is something we talked in current and electricity lesson. Now you see the ends of this electric component is connected with a connecting wire. Whatever the electric component is here, its ends are connected using a connecting wire. This is called the short circuiting. Short circuit when some electrical component is short circuited, there is no point of having it there. So that is, the equivalent resistance is not affected by that capacitor, because why? When this is short circuited, these 2 points will have the same potential. Points potential. So when they have the same potential, no point of having this, because it will not store any charge. Okay, now the equivalent resistance should be only given by these two resistors which are in parallel. That should be just 10. 5, 5, 10. So the new, we'll say closed, QC. The closed place, the charge is C2 times V, 10 into 50, that is 500. You see, initially it was 500 over 3. Now it is increased up to 500. So what is the new charge flown? So the charge flown should be the difference, right? The difference is equal to, if you do the calculation, the difference is equal to 1000 over 3. Just do it and see the answer if it passes. Okay, so that is given in the fourth option. That is correctly given in the fourth option. Okay. Question number 16. S1 and S2 are two monocentric shells containing charges Q and 2Q in free medium. The flux through S1 is phi1, the flux through S2 is phi2. Now a medium of permittivity constant 5 is inserted into S1. The flux through S1 is phi3. Find relationship between phi1, phi2 and phi3 is given by. So the flux through S1 is phi1. Initially it is free medium. Initially free medium. Free medium means epsilon naught. After that, after some time, the medium is, inside S1 is inserted with some medium with permittivity constant 5. Permittivity constant 5 means that is the relative permittivity. That is 5 times the free space permittivity. So initially it was phi1, this was phi2. So after placing this, the new one is phi3. Okay, simply you can tell the values for phi1, phi2 and phi3. That is just depending on the Gauss theorem. The fluxes dependent on Gauss theorem. So what Gauss said was the net flux is equal to net charge inside the Gauss surface divided by epsilon of the medium. So simply phi1 should be equal to, so if you consider the surface S1, inside that surface only Q charge is there. So the net charge inside is Q divided by, initially the medium is filled with free medium, that is epsilon naught. So phi1 is this. Phi2 also you can do the same way. So compared to S2, there are two charges inside. So altogether it is 3Q divided by epsilon naught. Then phi3. So phi3 is measured after replacing the space inside S1 with a medium permittivity constant 5. Now, still the charge inside S1 is Q, Q divided by the new permittivity, that is 5 epsilon naught. Okay, so what they ask, in the given answers, they have a ratio between phi1 and phi2. So if you take a ratio, what will happen? Phi1 over phi2, if you divide it, Q over epsilon divided by 3Q over epsilon. This is getting cancelled and it will be 1 over 3, right? And phi3 is Q over 5 epsilon naught. Both of these is correctly mentioned in the third answer. The answer is third one. Then the 17th question. The 17th question is a statement question about projectile motion. Two particles PQ and R present at the same point on a horizontal plane are projected with same speed at angles 30, 45, 60 inclined to the horizontal. Which of the following statements is true about their motion? Done. A. The horizontal ranges of particles P and R are equal. P is projected with 30 degrees angle. R is projected with 60 degrees angle. In projectile motion, there is a point. If you project with theta angle and 90 minus theta angle, in both cases you get the same horizontal range. يعني angle එක theta වලින් යවුවත් 90 minus theta වලින් යවුවත් එකම horizontal range එක එනවා කියලා තියෙනවා. හරිද? So 30 90 minus 30 කියලා කියන්නේ කවුද? 60 නේ. So these two angles should have the same horizontal range. That is correct. Me particle Q will reach the maximum height. Q is the particle projected at 45 degrees. If you project with 45 degrees, what is the what is maximized? 45 degrees means maximum horizontal range. Remember that. It is maximum horizontal range. That is not the maximum height. A projectile will reach the maximum height when the projectile is vertical. Like, if you want further explanation, the projectile will achieve a maximum height when its vertical component of velocity is maximum. Vertical component එක maximum වෙලාවට තමයි උඩම තැනට යන්නේ. So when the vertical component gets maximum when it is projected directly vertically. So that's wrong. Q is not the one which is having the maximum height. The one with maximum angle, that is 60 degrees, which is R. R will have the maximum height. Particle R collides with the ground with maximum vertical velocity. That is correct. R has the highest inclination with the horizontal direction. R has the highest inclination with the horizontal direction. So higher inclination means higher vertical component, which is when it is moving upward, as well as when it reaches the maximum height. When it reaches the ground, the same velocity will be there, but to the opposite direction. So the maximum vertical velocity when it hits ground is obtained by particle R. That is correct. D. All particles will hit the ground with same velocity. Yes, of course. If they are projected with the same velocity, again when it reaches the ground level, the same level, all three particles should have reached the same velocity, because that is the energy conservation, right? If at the same level, if the energy stays constant, then the same kinetic energy should be there. That is also correct. So the only false one is B. So only A, C, and D are true. That is third answer. Third answer. Question number 18. Closed tube vibrates with its fundamental frequency when 500 Hz tuning fork is placed as shown in the figure 1. Okay. The open tube vibrates with its first overtone with the same tuning fork as shown in the figure 2. Okay, so the second tube with length 2 vibrates with the same fork by the first overtone. Then the tubes are connected as shown in figure 3, its fundamental frequency. Okay. So the first tube is closed one, and with the fork it vibrates with the fundamental. The second one is having L2 length, and it is showing the first overtone. So for open tubes, the first overtone is this is the fundamental. The first overtone is something like this, having two loops, two halves and a full loop. The third case, both these tubes are connected together. So it should have a closed end, because this has a closed end. So when they are connected, one end should be closed, and the total length should be L1 plus L2. So the way the fundamental pattern to be which we have to calculate the frequency should be like this. Fundamental like a so we need to evaluate the frequency. Okay. So these two have the frequency 100 Hz because it is 500 Hz because it is vibrated by this tuning fork. Okay, so you can obtain formulas, and we will consider the first two figures, and then we will calculate fundamental using third one. Okay, so if you go for the first one, you can build up relationships for the wave pattern. uh, half a loop costs lambda over 4, if you remember. Full loop means lambda over 2, this is half a loop. So lambda over 4 is equal to L1 here. So lambda is equal to 4L1. Okay, but it is not the whole thing that you can obtain by this point. So when you get to this kind of an wave pattern, you apply the f equal f, so v equal f lambda to relate the frequency, right? මෙන්න මේ දෙකම දානවනේ පුරුද්දට ලියන්න. So the velocity should be equal to frequency 500 times 4L1. Okay, you obtain the first relationship. We will keep it and see how to continue with this. Okay, let me so actually what we need to do is we have to calculate this L1 plus L2 term. So that then I'll subject this L1. That is done with the reason. You will see it when it comes to the third calculation. Okay, the same procedure I'll do for the second figure. So there you get two full loops. 1, 2. Loop is lambda over 2. Two of them is equal to L2. For instance, the length, two loops is equal to length L2. So lambda should be equal to L2 for the second case. So when you apply V equal f lambda, you again can relate with the frequency. So V again should be equal to 500 into L1. So sorry, L2. You get another formula for L2, that is V over 500. And now we are going for the third one. To evaluate the frequency, you first need to calculate the lambda. Half loop lambda over 4 times 1 should be equal to L1 plus L2. You see? Now you get this L1 plus L2 term here. So I'm just replacing that L1 plus L2 term with these two formulas we obtained in the first two cases. That should be V 10200 2000 plus 10500 lambda over 4. So lambda should be equal to 4 times V. Here it should be 5 over 2000, right? So these two get cancelled and it will be 400 again. This will cancel 100. Okay, lambda will be equal to just V over 100. So now you can apply an V equal f lambda to calculate the frequency. So V is equal to the same velocity. All three cases, the velocity of air is the same, V. New frequency of note times lambda is V over 100. So getting cancelled, if not become 100 Hertz, which is given in the first answer. හොඳ ප්‍රශ්නයක් නේ. First two cases වලින් ගන්න data වලින් third එකට apply කරගෙන finally fundamental කෙරුවා. හරි. Just some mathematics, okay? This will make you the first. So the thing is that you have to see these questions at least a single time before going for the exam. So if you have seen questions in your exam paper before, then you at least have tried them at least one time. So when you get that experience, the next time you see it at the exam, you know how to, what to do with that question. So then you can, save a lot of time with those questions you have seen before going for the exam. So that's why you need the practice. So with the practice also there are two things. One is, with practicing the questions, you can develop your thinking patterns, as well as you can have your brain trained to solve problems. That is first thing. That is the important thing. And then the second thing is, when you see some questions you have seen earlier, then again you don't need to work. Newly you don't need to think of it. You already have solved it. So your brain knows how to deal with that question. So then in the exam, you will save some time solving those questions. Okay, so do questions. Okay. So question number 19. In the circuit shown in the figure, if the potential difference between A and B is V naught, potential difference between C and D is V1, then the value V naught over V1 is. Okay. So this is V naught, this is V naught, this is V1. You have to calculate V naught over V1. Okay, so you can do that after calculating this V1 in terms of V naught. So this is basically a potential divider circuit. We have analyzed this before in the class. So what happens is when you supply some voltage here, it will be divided through consecutive series connections, right? I mean, you have to identify the correct series connections. But after you identify them, what happens is this total voltage will be divided between each series connection. Okay. So we will find this V1 in terms of V naught first. So first of all, this V naught is supplied at these two ends. So now you need to take it to that point. So the first series connection is that when this is applied, there is an R resistance in series with this whole thing. This R resistance in series with this whole thing. So you have to evaluate a single resistor which can replace this whole system at this point. What is it? You see, you need to solve this now. Again, you have to identify series and parallel connections. So when you come to this point, 2R and 2R seriously connected. They are connected at the same ends. They become R. RR, now they are series. From here to here, a single path is there to flow the current. So that will be 2R. So this 2R with this R again in parallel. This 2R and this R is in parallel. So the equivalent value, if I take as R dash, it should be 2R times R divided by 3R, right? Product divided by sum. When they are in parallel, product divided by sum. 2R over 3. Okay, the single resistor which can replace this whole system is 2R over 3. And now you can divide the voltage for the first outer series connection. Series connection. So let's say the voltage you get for these two ends. Let's say it is V1. Okay. So V proportional to the resistance for series connections. So V1 is to V whatever the other thing. So if this is V1, the remaining should be V0 minus V1. The whole thing is V0. So V1 minus, so V1 is to V0 minus V1 is equal to 2R over 3 is to R. R get cancelled. Ratio comes as 2:3. Then you can calculate V1 in terms of V0. The total is V0. So divide it to 2:3 ratio. You first need to divide it to 5 components, 5 groups. And if you get a bunch of mangoes, let's say 10 mangoes are there. If you need to divide it to 2:3 ratio between two friends, what you have to do is we first have to divide these mangoes into equal 5 groups. So if you need to divide it to 2:3 ratio, you need to divide it to 5 groups. Then you take 2 groups and give it to the first person. For the second person, you give 3 of them. That's how you divide into ratios. So same thing done here. V0 is the external voltage. You divide it to 5 groups. Take 2, you will get V1. 2 V0 over 5. But our final goal is not V0. We have to calculate V1, right? So now you know the voltage difference between these 2 points. Let's say A, B, C. You know VBC is equal to this. If I take this point as B, this is also B, same potential, a connecting wire. Again, if I take this point as C, this is also C and this is also C. Okay. So when you know this V1, now again you need to go to this point again. V1 so now transfer it. මේකම තමයි මෙතනක් තියෙන්නේ. හරිද? BC BC. So at these 2 points also the same potential is there, V1. Now you consider the separate circuit. The separate circuit is B and intermediate there is another point and this is C. So between these two resistors, 2R. So this is V1. Now we have calculated this is, we can't take this as V1, right? Because V1 already there. So maybe I can take V2. Extremely sorry for that. You can't take already available symbols. Okay. So this is V2. So you got V2 potential difference at these 2 points. You need to calculate V1. Again, you have to identify the series connection and divide it. So when from B to C, this R resistor is series with this whole thing. This R resistor is series with this whole thing. This whole thing is 2R, that is R. A single resistor which you can replace that whole thing is R. So R. Again, we divide it to the resistance ratio, that is 1:1. So V1 should be, you need to divide V2 by 2 and take 1, right? V2 is 2V0 over 5. 2V0 over 5, if you divide by 2, it will be V0 over 5. And now you get V1 is equal to V0 over 5. What you have to evaluate? You have to evaluate V0 over V1, right? So rearrange this. V0 over V1 you get 5. So the answer should be third option. Simple potential divider circuit. Question number 20. I'll give you some interval after this question number 20. Take notes. An inelastic string is tightened at O and its free end is wrapped to the circumference of a pulley and released. The string has tension force T and its mass is M. What is the incorrect statement of the following? This is about the resulting motion. Statements are about the resulting motion. So what happens is they have brought a string over this pulley and it is connected to this ceiling point O and then released. So this pulley got some mass. There will be the weight force. So they are asking about the resulting motion. So the resulting motion, you can imagine that what is happening is this pulley getting rotated and this string getting unwrapped out of this pulley, and then this pulley will accelerate downwards. That is the resulting motion. So simply this pulley accelerates downwards while rotating with an angular acceleration. So both things happen. There will be a linear acceleration as well as an angular acceleration because of unwrapping of the string. So what are the forces involved? So you can write equations for these motion after you identify the resulting forces. Obviously weight is there and there is this tension force along the string. No other forces. These two are the forces. So the all two motions should happen under these two forces. This linear acceleration as well as the angular acceleration should happen by these two forces. We will first write for the linear acceleration. That is simple. Just apply an F equal ma. So mg minus t should be equal to its mass times the acceleration. That is how you relate the linear acceleration with the forces. And then we will consider the angular acceleration. This is a circular motion. Angular acceleration means circular motion. So for circular motion, the equation you can apply is tau equal I alpha. When you apply that, what force build up the required torque? That is the question, right? Remember, when we are considering the circular motion, you just have to identify that this circular motion occurs around the center of gravity at this point. So what is the force which can exert a torque about that point? Can weight exert a torque? No, right? Weight can't exert any torque around center of gravity. Why? That is going through it. So if the line of action goes through the point we consider, there will be no torque. There is no moment because the perpendicular distance is 0. So the required moment is given by the tension. That is equal to T into R. If the radius is R, then the required torque is given by T into R. That is equal to I alpha. This is the second equation actually. And there is a third equation. This angular acceleration and this acceleration again can be related by A equal R alpha. Okay, now we can see the statements. First one, torque which is needed to rotational motion is applied by the tension. That is correct. Tension supplies the required torque. Yes. The pulley pulls downwards with a constant acceleration. That is also correct. There will be two accelerations. One is linear acceleration downwards. The other one is the angular acceleration around the center. Center. That is also correct. 3. Weight produces the torque required to torque needed for pulley to rotate. That is wrong. Torque is supplied by tension. That is the wrong choice then. So fourth one and fifth one are also correct. So if you read them, when considering the motion of P, it moves vertical downwards with a constant. Correct. Direction of torque is normal to the plane of the pulley. Yes. So if the forces are in this plane, the torque, the direction is taken by the right hand rule. So if you curl the other fingers to the direction of moment, you get the direction into the board that is perpendicular to the board. So fifth one is also correct. Okay, so we will have a quick interval and after we will continue with the questions. First, composite solid cylinder consisting parts A and B is made of materials whose densities are 600, 200 respectively, kilograms per cubic meter. The height of A is 9 centimeter and that of B is 1 centimeter. The cylinder floats in water of density 1000 kilogram per cubic meter as shown in the figure. What is the height h of the cylinder underwater? So how much of this side cylinder will be submerged underwater? That is the question. Simply, if you consider the principle of flotation, what should happen is the upthrust should balance the total weight, right? The upthrust should balance the total weight. So the upthrust force, let's consider the cross section of the cylindrical section as a cross section. Then submerged volume I can write in terms of the submerged volume, submerged length. How? Submerged volume is equal to area times submerged height, right? AH times the density of the liquid, rho W, that is 1000, times D, that is 10. should be equal to the total weight. Weight is not mentioned, but the densities are. So when the densities are given, again you can calculate the masses, volume times density. By the way, there are two sections there. So the mass should be evaluated as a sum of two types of materials. So first volume, let's consider the volume of A. Volume of A is A into the height is 9, right? Let's say H1. And for the B, here it should be rho 1 as well, volume times density, plus the other one, A H2 rho 2. So I'm substituting with the values. A height 1 is 9 into the power minus 2. Densities, A's density is 600 plus A into 1 into the power minus 2 into 2000. A get cancelled. No zeros I can cancel again. 20. Then 10 also get, the whole thing I have to put G here, right? So that 10 is again cancelled. So NH equal 5.4, sorry, 0.54 plus 0.2. So H is equal to 0.074. That is the answer what I get. But in meters, you substitute all the values in meters, so you get the answer in meters. But the values are mentioned in centimeters. So to make it centimeters, you have to multiply by 0.4 centimeters. Given in third answer. 22. The given figure shows the wavefronts of a ripple tank which are generated due to the vibration of pointer of constant frequency. The system is used to demonstrate the Doppler effect. Okay, when the pointer moves, when the pointer is moving right side with a constant acceleration, the pointer is now moving to this direction with an acceleration. Velocity is increasing. Which of the following, which diagram shows the correct behavior of the wavefronts? Again, the correct behavior of the wavefronts. Okay, so when the source moves, in Doppler effect, we learn this. When the source moves, the Doppler effect is caused due to the change in wavelength. The apparent wavelength gets changed. If a source is moving with a constant velocity, remember, if a source is moving with a constant velocity, we have drawn this wavefront diagram for the Doppler effect. What happens is, if the source moves to the right, the wavefronts in front will have lower wavelengths. That means higher frequency. Higher frequency is heard if you stay before the source, but after the source, the wavelengths get increased. That means lower frequency. You can hear. So same thing happens in this case as well. But here the planar wavefronts are there. These are circular wavefronts. So, but in this case, planar wavefronts are drawn. So let's say this is the position of source. This is the position of source. So what happens is, source is moving to the right. Wavefronts in front of S should have lower wavefronts, but before the source, it should have higher wavelength. So lower gaps and higher gaps. Again, that has an acceleration other than the velocity. This one has an acceleration other than the velocity. So if no acceleration, this considering zero acceleration. No acceleration means these gaps stay constant. Acceleration and aggregate make gaps constant. But if there is an acceleration, the gap also changes. You think higher this velocity, think is in the base case. So if you consider the base case, higher this velocity become, lower the gap in front, higher the gap after the source. Wave velocity එක වැඩි වෙනවට ඉන්න මේ gap එක අඩු වෙනවා මෙහෙන් gap එක වැඩි වෙනවා. මුලින්ම මේක emit කරපු wave fronts තියෙන්නේ ඈතින්මනේ. So the wave fronts which lies ahead will have comparatively higher wavelengths, but when it comes to closer, the wave front should go very near to each other because it is accelerating. Accelerating means wavefronts are getting collapsed more and more. So in front, be like this. Then, if you go this way, the wavefronts always should have a higher gap. But farer wavefronts ඈතින් කියලා කියන්නේ ඒ වගේ මුලින්ම ගියේ. මුලින්ම යද්දි velocity එක අඩුයි. මොකද මේක දිග accelerate වෙද්දි මුලින් velocity අඩුයිනේ. So the gap is somewhat less. But when it comes to this point, the gap becomes again very high. So the gap is increasing to this direction, like this. So the answer which shows this correct behavior is the fifth one. This is correctly represented by the fifth answer. Remember that. So the difference in gaps is caused by acceleration. Okay. 23. Well insulated vessel 600 contains 600 grams of water at 30 Celsius and its capacity is 830 joule per kilogram. මේ vessel එකක දීලා තියෙන්නේ. 50 grams of ice at 0 Celsius is added to that vessel. Ice 450 grams. Ice means Celsius. Amount of maximum water that can be remained inside the vessel when the system attains the thermal equilibrium. Okay, so the amount of liquid water, maximum amount of water remain inside the vessel when it attains thermal equilibrium. Okay, so when you keep this ice here, when you heat will flow from the high temperature to the lower temperature, means 30 Celsius to the 0 Celsius. Then what happens is this ice get melted. So once the ice get melted, at the same time when the ice get melted, the temperature of water also decreases and it will reach 0. But when the temperature reaches 0, there will be some amount of ice remaining. You don't know the amount of ice. So they are asking the new volume of water. So how this new volume comes? Initially there was some volume. Now because of dissolving this ice, there will be some extra volume. So that's extra volume is the volume which transfers heat to the previous water. Okay, so we can evaluate this extra volume of water which is taken by ice, extra volume or the melted volume of ice, extra volume of water by melting. We can evaluate that by considering the heat flow. So that should be the that plus the previous amount will be the amount remaining inside the vessel when it attains the thermal. Okay, so heat released by water plus calorimeter vessel is equal to heat gained by ice. Heat released by water, mc delta theta, as is 0.6. Water specific here for 200. Temperature change, it's reducing this temperature to 0 Celsius, right? The thermal equilibrium is attained at the temperature 0 Celsius. What happens? Some part of it gets melted, but when melting ice, no temperature change, but the heat is absorbed, so the temperature will decrease, and both ice and water will attain the same temperature, 0 Celsius. So temperature is 30 minus 0 should be equal to plus there's some heat gain lost by heat given by this vessel as well. Vessel ki heat එක දීලා තිනවා. So when the heat capacity is mentioned, delta Q is given by C delta theta. 830 and then 30 minus 0 is equal to heat gain by ice. For a phase change, the heat is evaluated by cubical ml. Mass of ice which is melted, that is this mi, into specific heat capacity, latent heat of fusion, that is 335 into 10 to the power 3. Okay, so when you solve this, let me check. When you solve this, you should get the mass of ice melted as it should be 300 grams. So assuming the density of water, what should be the volume? Volume should be mass divided by density. The mass is 300 grams. Density of water is 1 gram per cubic centimeter. That thing you may remember. Cubic centimeter means milliliters. That is 300 milliliters. So initially there was 600 milliliters as well. Patangani 600. So 600 plus 300, the total volume is now 900 milliliters, which is given in fourth answer. Um, 24th question. There's a connection. So A point is maintained at 0 Celsius. This is maintained at 100 Celsius. This is maintained at 0 Celsius. And thermal conductivity of material AB is twice that of the material AC. That means if you assume the thermal conductivity of this is K, for AB it is 2K. And this is also K. AC and CB are same, that is K. In the steady state, rate of heat flow through AB and AC. Okay. So they are asking what is the ratio between the rate of heat flows. Q1 is to Q2. Okay, we can write the relationships. So you see, this is a perfect, a single connection, but from here to here, it is again this is a series connection. Fortunately, both these rods are kind of same, having the same length, equilateral triangle, having the same length, having the same cross section area. in the same, I mean, all three dots we can assume the same cross section area because it is not mentioned. So these two especially have the same length, same cross section area. So we can consider this as a single, I mean, this, even if it is broken into two pieces, we can consider this as a single rod because no any parameter changes. Other conductivity is same, area is same, length is same. So this mid temperature, I mean, when you have two rods in series, the problem you get is this middle temperature. You have to perform a different, I mean, to evaluate this theta, and then only you can evaluate the heat flow. يعني series connection එකක් තියෙනකොට අර මැද temperature evaluate කරලා තමයි heat flow එක හොයන්න වෙන්නේ. දැන් මෙතන ඉතින් අවුලක් වෙන්නේ නැහැ. මේක equal හින්දා මෙතන එන්නේ 50 Celsius. Okay, now you can compare directly. Q1 is to Q2. The heat flow is given by Ka delta theta over L. So Q1 කියලා කියන්නේ යට පාත් එක. හරිද? So 2K හරිද? constant එක 2K. A temperature change එක 100 minus 0 divide by length එක කීයද? Length is L. Then 2, yeah, Q2 means the heat flow through this AC. So for AC, the conductivity is K, area is A, the temperature difference from A to C is 50, 100 minus 50, and the length is again L. Getting cancelled all distance, you will get this to be the ratio is 4. That is given in the fifth answer. That is given in the fifth answer. 24. The answer is 5. Okay. Then 25th question. Consider the following statements about an astronomical telescope and a compound microscope. Statement A. The focal length of the objective lens is, in astronomical telescope it is large, compound microscope it is small. That is correct actually. In astronomical telescope the focal length of objective is high. That's how you obtain the magnification. If you remember, the magnification is given by f over fe. So you need to have a higher focal length for the objective to have a magnification. Okay, it should be greater than 1. That is correct. B. The final image at normal adjustment for astronomical telescope they say infinity. Compound microscope also they say infinity. That is wrong. For astronomical telescope it is correct, but in compound microscope case, in microscopes we always take the normal adjustment at where? Normal adjustment is always taken at the nearest point, the least point, at the least distance of distinction. Okay, C. The total angular magnification is less than 1, greater than 1. Okay, so that is wrong. Both these optical instruments, it does not matter astronomical telescope or compound microscope. Any microscope, any telescope we use to magnify smaller things, things we can't see. So if the magnification happens, then the magnification is all, I mean, angular magnification should always be greater than 1. In both cases, it should be greater than 1. So C is also incorrect. So A is correct, B incorrect, C incorrect. Answer is the first one. So first one is the correct answer. Okay. Then 26th